Civil War soldiers stuffed grass into their clothes and survived frozen hell winter used to kill faster than bullets. Long before battery-heated jackets, chemical warmers, and insulated tactical gear, desperate soldiers discovered that the dead grass under their boots could become a life-saving shield against brutal cold. During harsh 19th century campaigns, freezing camps turned fields into survival laboratories. Men stuffed dried prairie grass inside coats, pants, blankets, and boots, creating crude insulation systems that trapped body heat with shocking efficiency. It looked primitive. It smelled earthy. But in sub-zero conditions, this rough survival trick worked like hidden technology pulled straight from the future. Cold weather warfare in the 19th century punished armies harder than most people realize. Soldiers often marched through snow with soaked socks, thin wool uniforms, and almost no reliable winter shelter. Supply chains collapsed constantly. Blankets became soaked from sleet and river crossings. Fires revealed camp positions to enemy scouts. When temperatures dropped overnight, frostbite spread fast across fingers, ears, and toes. In those moments, survival depended less on military training and more on adapting to the land itself. That is where dried grass entered the story. Soldiers camped near prairie regions noticed that tall dead grass stayed surprisingly warm even after hard freezes. Bundles of it remained dry beneath snow layers because frozen air moved around the stalks instead of crushing them flat. Once stuffed inside clothing, the grass created thousands of tiny air pockets. Those pockets trapped warm air produced by the body and slowed the escape of heat into the freezing environment. The effect was simple physics, but the results felt almost unbelievable to exhausted troops. Modern thermal studies explain why this old tactic worked so well. Heat escapes through conduction, convection, radiation, and evaporation. Grass insulation attacked several of those problems at once. The hollow structure of dried stalks reduced direct heat transfer. The loose fibers interrupted airflow that normally stripped warmth away from the skin. Wool layers combined with packed grass formed a barrier filled with dead air space, which is one of the strongest natural insulators on Earth. Even modern cold weather jackets still rely on this same principle. Synthetic insulation traps air. Goose down traps air. Dried grass simply did it using materials growing wild across open land. Late-season tallgrass worked best because the fibers stayed strong after drying. Thick prairie grass, hay-like stalks, and mature field grass all held shape better than soft spring growth. Soldiers gathered armfuls before nightfall and kept them dry whenever possible. Wet grass could freeze solid and destroy insulation performance, so preparation mattered. Experienced survivors shook dirt loose, crushed stiff stems slightly, and fluffed the material before stuffing it into clothing. That lofting process increased trapped air volume and reduced uncomfortable pressure points while moving. Boots received special attention because frozen feet ended survival chances quickly. Soldiers wrapped grass around socks or packed it directly into oversized boots. The dry fibers absorbed small amounts of moisture while maintaining airflow around the foot. This slowed sweating and reduced dangerous heat loss. Some troops even rotated fresh grass into footwear daily, throwing away damp material before it could freeze overnight. That basic field hygiene prevented blisters, trench foot, and icy skin damage during long winter movements. The method also worked inside bedding. Grass stuffed between blanket layers created emergency sleeping pads that blocked frozen ground from draining body heat. This mattered more than most people understand. Cold soil constantly pulls warmth downward through conduction. A person sleeping directly on frozen earth loses heat rapidly, even with heavy blankets overhead. By placing dry grass underneath the body, soldiers created a thermal break between themselves and the ground. In survival terms, that small layer could mean the difference between sleeping safely and waking up hypothermic. Modern survival experts still test this forgotten technique during winter field exercises. Thermal cameras reveal noticeable temperature retention once grass insulation is added beneath outer layers. Core heat remains more stable during stationary exposure, especially when combined with wool clothing and wind-resistant shells. Mobility decreases slightly because the extra bulk restricts movement, but the warmth gained often outweighs the inconvenience during emergencies. In a modern grid-down disaster, this old battlefield trick becomes surprisingly relevant again. Power outages during severe winter storms can shut down electric heating for days. Fuel shortages can limit generator use. Emergency blankets eventually fail once soaked or compressed. But dried grass, reeds, and similar forage materials remain available across huge rural areas. With basic preparation, they can reinforce jackets, line sleeping bags, insulate shelters, and protect extremities during freezing nights. The key is layering correctly. Moisture control comes first. A thin inner layer should keep sweat away from skin. The grass layer belongs in the middle where it stays protected and dry. An outer shell blocks wind and snow from collapsing the insulation. If the grass becomes damp, it must be replaced quickly. Dry material performs dramatically better than wet material, especially below freezing. The biggest lesson from this forgotten survival system is not about grass itself. It is about mindset. 19th century soldiers survived deadly winters because they stopped viewing the landscape as empty terrain and started treating it like equipment. Every frozen field became potential insulation. Every patch of dry stalks became stored heat waiting to be unlocked. That same thinking still matters today. When modern systems fail, old knowledge suddenly becomes cutting edge again. What makes this story fascinating is how close this method comes to modern survival engineering. Expensive insulated gear now uses advanced fibers, layered chambers, and thermal barriers, yet the core idea remains nearly identical to what freezing soldiers discovered in open fields more than 150 years ago. Trap dry air. Protect it from moisture. Keep wind away from the body. That is the formula. The technology changed, but the survival science never did. Sometimes the solution is not hidden inside a store shelf or factory. Sometimes it is growing beneath your feet.